So it's great to be here. I spent a few years at New Jersey. I worked at Bell Labs for a few years before I decided I needed to move to a colder place, and that's what took me to Boston. So I'm here to sort of take a few minutes of your time and share with you an interesting idea, this concept of a big data as a service. People have talked about it in the last few years, but I just wanted to come and share some of our observations. We've spent time with quite a few companies, small and large, thinking about big data and cloud. And some people will tell you it's super easy. All you do is you spin up a Redshift cluster, you spin up an EMR cluster, and you get going. And then you talk to the people who are, typically larger companies, and they're trying to do analytics for a living, and they'll tell you that it takes a lot of effort and time and expertise, so that's the world that I wanted to talk to you guys about. So again, I'm Prat Moghe. I'm the founder and CEO. The name of the startup that we started 3 years back is called Cazena. Matt, it's Cazena. Yeah. And yeah. What accent is that, by the way? And Cazena stands for treasure in several Indian languages. So it's really interesting to see analytics move to the cloud. Now many of you are young enough that you don't know the world before cloud. But and if that's the case, then this talk may not be interesting to you, but in some sense, it's also interesting for if you are a data scientist, for example, you have the same issues that you see face many of these larger companies that are thinking about cloud and big data. So the first observation is there are two things going on in analytics, two interesting things shifting at the same time. The first thing that's shifting is the data center itself is going away, right? And cloud's coming along. So it's the platform shift of data center, infrastructure, and cloud itself. Like if you look at the big banks around you, many of them are still in the data center. Like I come and preach cloud every day, every week I'm here, and people will be like, yeah, it's coming, the cloud's coming. I'm still waiting. So that's one shift, right? And you can see why it's hard because of complexity, because of security issues, real or perceived, and obviously resources. Like you need DevOps people who really understand cloud well. And then just as you start to think about the cloud, what do you bet on? I mean, AWS was a clear leader a few years back, but now Azure's come along and then Google's there. So the whole question is, if you start to move from the data center to the cloud, what do you bet on, right? So it's sort of the analogy would be like when you had hardware, who did you bet on? Did you bet on Sun? Did you bet on Dell? Did you bet on HP? And do you think of the cloud the same way? And if you did think of the cloud the same way, then you got to think about building to each of these guys, not any one, but all of them. How do you do that? And obviously, there's a lot of Kool-Aid around the cloud, right? Like agility, fast, like you can go really fast, really efficient, turn it down when you don't need it, and reduced cost. But the reality is all of this is not easy. And reduced cost, the cloud is, I call it the open bar. So if you go to an event and you say, oh, it's only whatever, $5 a glass, it doesn't feel much. But by the end of the evening, if you are the host, you're tallying that thing up, it adds up pretty fast. And so like in our startup itself, like I've been shocked. Like I have a CFO watching my cloud costs every day. Because if you don't watch them, quickly you spend $50,000 without even knowing it. So we talked about the cloud as an infrastructure itself. Then you add another dimension to it, which is the big data dimension itself. And here interesting things are going on. That stack is completely disintermediated. In the old days, you had SQL, and it was Teradata, Oracle, IBM, SAP, Microsoft, a bunch of these. Hadoop was a tiny dot. And now you look at that stack, it's completely different, right? It's Hadoop, it's Spark, it's Python, it's R, and it's like every 3 months there's a new open source project around it. And you look at it and you say, oh, this is great. I got a lot of flexibility, a lot of innovation, I can move fast. Hadoop feels cheap. What's there to worry about? But then you look at this and you say, can you actually hire a good Hadoop DevOps engineer? Is it easy? I mean, you saw somebody stand up here saying they're recruiting. There's a reason, and it's because it's really hard to find these people, right? And just when you train on something, there's a new thing going on. There's a new project, right? And so constant churn, you're trying to keep up with that churn. The only thing constant is change in this stack, right? And then the other thing to think about is that your resources are constrained. You want to try and move to the cloud. You want to do big data. How do you do it? That's the issue that we are seeing. So these two challenges come together. So what we did is, we went and talked to a few interesting companies around here: FINRA, NASDAQ, Capital One. I mean, these are like really cutting-edge, large companies that have actually retooled themselves, right? And they've said they're going all into the cloud. They're going to do big data in the cloud. And you go and talk to them. You go and actually understand a typical project. When somebody who's analyzing terabytes of data, petabytes of data, what does it take to take all of that and do this in the cloud? If you're a small startup, it's easy, right? You can just start in the cloud. You can get going there. But if you are somebody who's has legacy data and you're doing some analysis and you're producing reports, you're producing campaigns, you're producing operational insights, time, SLA, cost matters. What we've done is we've actually looked at how long it takes for these companies to actually move in the cloud and build around AWS, build around Azure. I don't expect you to actually read through all this stuff, but the point is, it's really, really complicated. You gotta find, like I get this question a lot. What's faster, Impala or Redshift? Right? And that's the wrong answer. And then what about Snowflake, by the way, right? And then what about S3 versus Blob Store? If you're trying to run certain queries, where should we place them? How should we size them? How many nodes do I actually need? Do I take the SSD version or do I take the disk version? All these options. AWS has 22 SKUs. It gives you all kinds of flexibility. You can configure it the way you want, but that complexity comes at the cost of expertise, right? You need somebody to understand all of those. So just provisioning what you need in analytics from the cloud itself is a dark art. Like I give you a workload, I give you a certain data, and I say, okay, you want to run something on this, it's got to return results back in 3 seconds. Tell me what you need in the cloud. Not easy to do. So that's the provisioning challenge. How do you connect AWS or Azure to your existing data flow that's sitting in maybe your data center or in a bunch of sites? How do you weave that? That's almost like it's like a heart bypass. Like you create a heart, now you got to connect all the arteries, you got to move data back and forth. Everything better work. If something goes down, what went down? Where did it go down? How do you fix it? Not easy, right? And it's not just sending the data to the cloud, it's also connecting all your analytic tools. Maybe you had Tableau, maybe you had MicroStrategy, maybe you had BI, SAS, ARC jobs. How do you route them? Do you place them in the cloud? Do you place them on-prem? How do you connect this whole thing? Think about security. Well, like security is one of those things where people are either completely afraid of the cloud security and they say cloud's not secure, which I say that's just not true. Cloud has a lot of great security controls. But the reality is it's a lot of work to take all of those controls and lock them down. Cloud, by default, is an open house. What you have to do is take every lock and key, close it, lock it to the right way, and connect it to the enterprise so that your security officer says, yes, this is the way I configure every system on-premise. That's the way I've locked up the cloud. No public IP addresses, making sure data is encrypted going in and out. Keys are integrated to some HSM. Logs are kept. Everything is transparent. Role-based access control is in there. It's like a whole bunch of controls you got to put on top of cloud. It's just not about spinning up a cluster. Who's accessing the data? What are they doing with it? I think you'll hear Satyan talk about the data aspect. And let's say you spin up something in the cloud, it starts running, you got data in there, you're analyzing data, you're running Spark, you're running Python, you're running, how do you patch it? How do you upgrade it? What happens when it goes down? How do you do backup? Where do you do it? We heard about S3 going down recently. What do you do when S3 goes down? Oh, that never happens, right? So think about it. Which region do you pick? If it goes down, what do you do? What's your plan? So that the jobs still run, the batch reports still run, customers still don't penalize you. And then here's the interesting thing, like if something goes down, who do you call? Anybody been on an AWS support line recently? And they're doing their best, by the way. It's just that it's the sheer numbers. Like, and by the way, if you put Cloudera on AWS and there's a problem, who do you call? And now you stick RStudio and there's a problem, who do you call? And then you try and move data from an ETL tool and there's a problem, who do you call? Where is the problem in all of this? So think about all of these as you're thinking about big data in the cloud. It's easy as a concept, but when you actually run a service, the nice thing about this new stack is there's so many new things that are coming. You can connect them together, but that also creates complexity. So you want to make sure when you build everything, it's all, in some sense, you're abstracting from each of these tools so that when you're looking at a problem, it's not specific about Redshift, it's not specific about AWS, it's not specific about the tool. You're looking at this as a broad, abstracted thing, and tools can come in and go out, but you still get a consistent experience. Does that make sense, guys? How long do I have? Super. So 3 clicks. So that's, again, I was told not to do a Cazena plug, but can I talk about Cazena for a minute? Yes. Okay. So what we are trying to do is essentially try and take all that surface and make it simple, right? It's sort of like the utility today. Do you know where you get your electricity from? Do you know the power plant? Do you know if it's coal-fired or nuclear-powered? Somebody said yes, and that's really scary. So then why do you care if this is AWS and Redshift and Azure in the East region and all that? Should you care? No. So sort of our view is that a true big data as a service should be like the grid. It's utility. I give you a socket, a cloud socket, and you should be able to plug in. And you should be able to say, I'm going to plug in Tableau. I have 0.5 terabytes of data, and I want to report, I want to run a query run in 3 seconds or less. Or I'm running a data engineering job on Spark, and I got certain SLA, and I have certain price points, and go run it for me, right? And I just plug it in. And that's this concept of 3 clicks, 0 DevOps. And that's what we are doing. And what that requires us to do, this is the stack that we are building, is at the bottommost layer, you got cloud, which is AWS or Azure. On top are these interesting best-of-breed big data technologies, right? They could be SQL, they could be Spark, and we picked certain tools here. We picked Redshift and Greenplum for SQL. We picked Cloudera for Hadoop and Spark. We've added RStudio for data science. But we continue to add more and more curated technologies in here. And our focus is really these 4 things on top. For this to be easy for you, it's making it easy for you to provision. So you should be able to say, give me, just run this for me, and the system sizes, auto sizes for what you need. It's production operations. So when it goes down, it knows it goes down. You don't have to worry about where the issues are. Comes with security and compliance. And then finally, it does all the data management. So moving data in, holding it, backing up, archiving it, all of that, and integrating with your tools. So the idea is that if you got Tableau, or you have Data Robot, or you're trying to run ML, you would just plug in to the top, depending on who you are. If you're a BI person, you plug in here. If you're a data engineer, you plug in the middle. If you're a data scientist, you plug on the right side of the stack. So that's what we are building. So if you're interested in learning more about this idea and collaborating with us. I'd love to talk to you guys. Thanks, Matt.
Join me for a few minutes, and I'll just start with one question, and then I'll turn it to two people. So terrific. How does it work with hybrid environments? So this is great if you have all your data already in the cloud, but the reality for most enterprises is that it's a little bit in the cloud, a lot in legacy systems. How does that work?
Yeah, that's a great question. So with Cazena, the idea is that there's a gateway, and you would download a gateway, and that gateway would sit on premise. So wherever you have data on-prem, maybe it's an Oracle database, maybe it's some ETL tool, and that would point to that gateway, and the gateway would suck the data, encrypt it, and move it into the right environment.
So you move it, you don't virtualize it.
You actually physically move the data. Yeah, that's right.
Great. All right, do we have?
If you move the data, it will not cause any performance problem because you're moving a lot of data, petabytes of data, especially with the network part is your bottleneck.
Right. So the question was like, what about the data and the physics of data? So there's that, you got to differentiate data from daily data, the new data that's being created every day, from the history, right? So in general, when you build a data warehouse, you got a big history, right? There are easy ways to move that history, but it's not through the pipe, right? You use things like Snowball and a bunch of other physical techniques to go ship that data. The daily increment typically we found is usually in a few terabytes a day. It's rarely petabytes a day. I haven't still seen a shop that is generating petabytes a day. And as long as you have a few terabytes a day compressed, it's not a big deal. As long as you have a direct connect to the cloud, that can be managed.
Hi, very nice presentation. Thank you. I have a couple of questions about the business model and how you guys are thinking about that. So there's, I'm interested to hear who you think's in the competitive landscape. Like I'm familiar with Cloud Nexa, I'm sure you are, and other players like that who try to hide a lot of the complexity of using the cloud for smaller companies who don't have the technology. But I'm interested when you get into bigger companies as well who have really smart and knowledgeable people. My sense is they want to kind of get under the covers and make the choice of Redshift versus this and that. So I'm interested in what your experience has been, both with the medium-sized companies and the larger, maybe more sophisticated companies.
Yeah, that's a great question. Our focus, by the way, is typically medium to large companies, and the place we're focusing on is line of business. So the head of analytics or the head of BI, and those people, if you just talk to them, for them it's all about speed. How fast can they move, right? So I think the days are changing where people have hundreds and hundreds of DevOps people that can build everything, touch everything, and right. So what we're seeing is actually the very different experience where they want to move fast. They want something that just works. And they do want something that's blessed and approved by their IT groups, right? And so the idea that when you build something like this, it's secured, it's managed and controlled by the IT people is an important distinction. So we haven't seen, we will occasionally get this thing of like, oh, how about this? How about that? And we are like, nope, you don't do it. So, right? There's a big market for DIY that people will build themselves, and that's great. But, we call them tech pioneers, but there is a whole challenged majority right behind tech pioneers where people want to move fast, but they don't see value in replicating the build. The value is really in the analytics and the outcomes. So.
Gentlemen, could you please raise your hand?
Hi, thank you for the presentation. How do you address the data lineage when you have multiple possible cloud providers in spaces where you have highly regulated data, financial health. So how do you keep track of what's where, what was where at what point?
Right. Well, that's a nice lead up to Satyan, right? You'll hear from him. But in general, the cloud is no different than on-prem environment, right? Like you got lots and lots of sources, and you don't know where the data is, and you want to know who's accessing the data. So we provide, in this stack, we provide for access to bring in third-party tools that allow you to do that, whether it's data discovery, whether it's data governance in terms of who's accessing what. Some capabilities are provided out of the stack, but the rest you can supplement with third-party tools, right? And they're available. And Satyan can talk about some of his approaches, but Alation is a good data discovery tool, for example, that allows you to keep track of what is where.
Great. Well, that's indeed a wonderful transition. Thank you so much.
Thank you.
This was terrific.
Thanks, Matt.
Prat from Cazena.
Cazena.